So I have done a lot of work related to Docker and Docker Compose, and like work that is related to starting up the application in different environments. So right now, like I haven't ported the actual code base of the previous project to this one, like the main core logic, but everything else I've kind of like completed. So I'm going to showcase it to you, like all of the work. So the first thing that I've done is that I've changed the package manager, the node package manager that was being used in the project to PNPM from NPM. PNPM is a newer node package manager which is very fast compared to NPM and also utilizes caching, which makes the installation of packages faster and saves time in different environments. Uh, and one more thing is that for installing PNPM, we don't have to do any additional thing. Yeah, actually, Node.js now ships with a package called CorePack, which installs the package manager along with a package manager for the project it is being used for. So, like CorePack, in the package.json file, there is a field called engines and a field called package manager. So what CorePack does is that it detects package manager version will be, uh, what manager version is being used in the project, and it automatically downloads it and installs it on the user's computer system. So people don't have to install a separate package manager here. All they have to do is just install Node.js, and everything will work just fine. Uh, there's also this new file .npm.rc. It shouldn't bother you too much because it's just used for configuring PNPM. And I don't think the settings need to change here except for the node version, which is required as we update node version in the project. After that, I've created plugins for Postgres, MinIO, Redis, and for uh, parsing and validating the environment variables on server startup. So this plugin is called an env config. So what these plugins do is that they attach the instance of the module they are trying to configure on the global Fastify instance, and after that, that module is available everywhere that Fastify instance is being used in the code base. So what this does is that it prevents memory leaks and uh, also prevents developers from reinitializing clients for databases and other third-party services. So it prevents like a server timeout. If for each little task you initialize a new client, it will like the remote service that you're connecting to will time out because it can't handle too many connections at a time. So basically, it helps prevent that, and it also helps gracefully shut it down when the server is shutting down. So like it will automatically handle disconnecting the client from the database or the third-party service so that we don't have to do it manually. So the plugins here are for Postgres, and by Postgres I mean Drizzle client, Drizzle ORM, which I am working on during this GSoC 2024. Other than that, there's env config, which automatically parses and validates all the environment variables which are used by uh, the Lava API at runtime. So it basically takes the process.env global context and parses it for all the variables and verifies that they are present and they are present in the form and shape that they are meant to be. After that, there's MinIO. This connects to MinIO and validates that the connection has established. And then at the very left, we have Redis. This too connects to the Redis server and make sure that the connection has been established. If any of these connections to a third party services like Postgres or MinIO fail, then the whole server initialization step will fail and it will throw an error. So we will know beforehand that one of the services failed to connect, so we can check for errors where they occurred. Like I can show it to you right now. This is a script I've prepared for starting the server. So as you can see in the log, it's first trying to connect to the Postgres server. As you can see, this is the log. Uh, this one, checking the connection to the Postgres server, right? And then we find that it can't connect to the Postgres server, so it enters this catch block and exits the process. So basically, the Fastify server never starts, the Lava API server never starts, and we break out of the process. So then we have to find out why it can't connect to the server, like if the server is not running or if the environment variable is incorrectly configured. Other than that, I've prepared the Docker and Docker Compose configuration for the Lava API. Right now, I've done it for development and production environments. I haven't done it for CI/CD pipelines because I have to study a bit more about that and how Docker works in CI/CD pipelines and how to do all that. So as you can see, there are all these statements from base, from the Lava non-root user, all of these are called Docker build stages. So basically, there are two main build stages here. One is production and one is development. The development build stage is used to produce a Docker image for development environment of the Lava API, and this one will have more dependencies and more tools, which will be used by uh, contributors of the Lava API during development time. And for production, we have a different image because in production, we don't need all the packages and all the files and folders that we use during development. So this way, the size of this image will be very small compared to the development image. So like I have calculated that the size of the production image is like 200 megabytes, and the size of development image right now is like 600 megabytes. But that's like 66% reduction. So that's a great thing. Other than that, I've prepared Docker Compose configuration for development and production environments. The compose.yaml file currently holds all the configuration that will be used by the Lava API in its production environment. And compose.development.yaml file holds all the configuration which will be utilized by contributors of the Lava API on their local systems. This will not be executed in the production environment because it's not needed there. So I will now showcase to you how this works. We are like currently checked out in the folder. This is my current folder. I'm using Git workspace. If you don't know about it, don't worry. So basically, I just run Docker Compose up and it starts building everything. I have pre-prepared the images, so the build is very fast. But if you run it for the first time on your PC, it will be kind of slow because it takes time to download the images and build the images. So as you can see, there are logs. First is the log for Redis, Postgres, then it is for MinIO, then it is for Caddy, and then it is for the Lava API. I've named the Lava API just API in the thing. Sorry. In the Docker Compose. So it is named just API and not the Lava API. So how I've done it is that at the very first, we start the Redis server and Postgres server together. And then once they have started, we make a health check request to Postgres and Redis server. Docker makes a health check request to check if their health is, if they are in a healthy condition. And after Docker has found out that they are healthy, it starts the API service. Then when the API service starts, it does all that stuff like checking the connection to MinIO, Postgres, and Redis. And after API has successfully started, it starts the Caddy server. Caddy is being used as a reverse proxy here. It will not be required in development environment, but it will be required in production environment for providing secure connection, for exposing the Lava API as a secure connection to the outside world. Like the machine on which the Lava API is being run, it will have a unique IP address which will be exposed to the outside world, and using any of the uh, domain name providers, we will assign that IP address a domain name. So caddy will just so this environment variable right here, the Lava API domain name, we will just substitute the value for that domain name as an environment variable in this file, and then caddy will expose the Lava API over HTTPS in production environment so that people people can access the Lava API over a secure connection. So I can show it to you right now. But this right here is the caddy server exposing the Lava API in over HTTPS. It is a browser because the certificate is local and not authorized by any genuine authority. The browser is complaining that it is not secure, but it works. Everything here works, right? So this is an endpoint health, which I have. This is the endpoint. You see, it is sending back health okay and 200 status score. This is what's being returned here, and this is a secure endpoint HTTPS, right? And by the way, there is no port here because by default the port for HTTPS on most of the operating systems is :443. So it basically removes that port and displays it to you just like that. Actually, if you make it 443, I think it would still work. Yeah, as you can see, it just disappeared because it is the default port, so browser already knows where it has to connect. Anyway, compose of development.yaml, as I said, is only used in development environment. And what it does is that it exposes things which contributors to Talaba API can use during development environment to ease their work. These things are not necessary, but they are provided as a default for Talaba API contributors to use. But they don't necessarily have to use this, and I'll show you later how to disable these services if they don't want to use it. So let's look at the things. First, what I've done is that in production environment, the Lava API won't be exposed to the host system. It will run in its own container, and the caddy service shares a network with the Lava API service. As you can see, here's the API network, and here's the API network for caddy. Both of them share the API network, so caddy can internally access the Lava API in production environment. So we don't have to expose the Lava API in production environment to the host system. It runs within the container. In production environment, we only expose the caddy service to the host system. As you can see, here are the ports. I'm exposing port 443 in the container to the port 443 in the host, and port 80 in the container to the port 80 in the host. And also this one is for HTTP3 connections. That is a different thing. We don't need to worry about that. So here in the compose.development.yaml, we are also exposing the Lava API to the host system, because if developers want, they can directly interface with it without going through the caddy HTTPS service. They can directly check out the thing. So how it is done is that if you go to we have to first learn about this actually. So how we control what services like what containers the Docker Compose should start in environments is that we make use of Compose profiles environment variable and Compose file environment variable. So these are all the profiles, or you can say containers or services, which are being used in the Docker Compose configuration, and you can control what services or containers you want to start. So the services that you want to start, you can list here using commas, and these services have to match this thing. Each of the container services in the Docker Compose files have a profile field which assign them a unique profile name. So you have to use that profile name in this environment variable to configure whether you want to enable or disable that service. Right now, I have enabled all these services in both in both production configuration and development configuration of Compose. Or in this right here, Compose file environment variable. This is used to mm, uh, merge different Docker Compose configurations into one. So because I'm right now going to show you how the Lava API works in development environment. I have mentioned the compose.development.yaml file along with compose.yaml, but in production we just have to we either we don't mention it at all or we just mention compose.yaml in this environment variable, so that only production services and production configuration are used and development configuration is not used. So I will show you again. This right now what I was showing, if it was actually for production, not development. I'm going to close all the containers and then reopen them. Now all the containers which I have specified in both these files, all of them will start, which is used for development environment, of course. It's downloading something. Oh, we'll have to wait, I guess, at least half a minute. Are you guys listening?
Yes.
Okay. I thought my internet connection went out or something. Yeah, so it has been downloaded. Now it's starting. As you can see, these are all the containers that are currently running. We have Caddy, we have the Lava API, we have Redis, we have Minayo, we have Postgres. We also have two additional services now. We have dbeaver, CloudBeaver, and we have Redis Insight. What these are called, what these services are, that they expose a web admin panel for managing Postgres and Redis. So in development environment, the Lava API contributors can use these web admin panels to manage their Postgres database or their Redis database. So right now everything has started. So I'm going to show you. So by default, as you can see, in development environment, the Lava API is accessible on the host system by default because I have exposed it. So this is the default address I have configured for CloudBeaver, which is a web admin panel for managing Postgres. I have also configured the default username and password for this, so people don't have to manually do it. You just have to come here and log in. The default username for everything I've set up as the Lava, and password is just password, PASSWORD. Now we have connected. We will make a connection to the PostgreSQL server. The database is also named the Lava for now. The host here is Postgres because this dbeaver CloudBeaver service shares a network with Postgres, so it will internally resolve this host to be to the container in which Postgres is running actually. We can enable all the databases instead of just the one that we are meant to use. We create this. Now we can open this. Go to the database and you can see here's the database we have configured for the Lava API. Right, and then within this you can do whatever you want. Everything is in here. Schemas. Here's the public schema. You can open it. It has all the tables and everything that Postgres gives us. Right now, there's no data in the database because I have not seeded it, but When there's data available, it will show up in this column, and then you can edit or delete or change it, whatever you want. You can mutate it. Other than this, there's the MinIO console. I think the person who's working on MinIO have already shown you this, right?
Right.
Yeah, so they're basically the console. And it is only accessible in the development environment or not in production. This right here is the Redis admin dashboard. Here you can manage the Redis databases on your local system that are running in the container. Like I can connect to it right here. Once again, this is sharing a network with the Redis Docker container, so we have to mention Redis here. Sorry. Yeah, we have connected. Now we can just start working here. Anyway, so this was for development environment, right? Once again, we still can access the allow API server over HTTPS if we want. It is over HTTPS, as you can see. So this was for development environment. We don't need all this jazz in production environment. So for that, we just need to specify these values for these environment variables. We don't need Cloud Weaver and we don't need Redis inside. And we also don't need MinIO console. For that, we have to change the value of this environment variable MinIO browser to off. It will not expose that MinIO browser anymore. Now we just build it for the production environment. Now we can't access these three services. You'll see later. See, I refresh this. We can't access this. We can't access this. We can't access this. Because this is for production environment and we don't need it. We can still access the caddy thing. We can't access the API because again, it is not exposed in production. Okay, that's all for the Docker and Docker Compose. Okay, there's more actually. So I have documented the environment variables in this file. I mean, this file can be changed if people want to display these environment variables differently, but right now this is what I have documented it like. So here all the environment variables for all different environments are documented, so people can read it and understand what environment variable they have to use, how to configure the Lava API. Other than that, I have also documented the scripts which are used in package.json file. These scripts, I have documented all of them here. Wait. Other than that, I have tried locally setting up a dev container for the Love API, and I did succeed in setting it up, but I was confused how the workflow for this will look like because when you're developing within the container and you make a change and you like push it to GitHub and then you sync back your your container workspace with the changes which are coming from remote GitHub. What happens is that the container will be rebuilt and all the things that you were doing in the container will get reset.
Oh.
It is like an operating system reinstall each time you rebuild the container. So I think that workflow is very kind of stupid.
Mm-hmm.
Right? Like everything you've configured within the dev container, like your user preferences, your local settings, everything, it will all get reset each time you fetch changes from the Lava API GitHub repository and something has changed. which which will need to be rebuilt, which will require a rebuild of the containers, and you will lose everything within the container. So I'm not sure how the workflow of this thing should look like, because I think this technology is not mature enough right now. We can provide it as a thing for people to test out, but I don't think this is usable right now.
Okay.
Or maybe I'm just not. Uh, I just don't know how to configure it so that it doesn't lose its state after a container rebuild. So, uh, other than this, the other way of doing this would be for people to make changes on their local system, and those changes have to be synced into the Docker container at runtime. So whenever they make a change in their in these files and on their host system, these changes will be transmitted to the Docker container, and all the processes within it will restart automatically. So they can see the changes, and so it is like a watch mode, right? It watches for changes on your host system. That is like a old approach how Docker development environment works. It is not a new thing. So maybe we have to go with that.
Mm-hmm.
The other thing was that we can set it up using Nix, right? Nix package manager. But 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 Nix by itself won't solve any of the problems that I'm talking about here, because all Nix will do is install the dependencies which are required by Talava API. It will not configure the workflows which are required for the third-party services that Talava API is using, like all these containers and everything. Nick, I'm pretty sure that the person who submitted that pull request for Nix configuration did not account for all this,
Right.
in starting all this stuff in development environment and stuff, like all the workflows related to it. All they did was install the dependencies that are used by Talava API itself on the host system, and that's all they did. So Nix by itself won't solve it unless you, I guess, develop a advanced Nix configuration, and you also teach people how to use Nix.
Right.
Yeah. Well, and Nix also there's also a constraint with Nix, is that Nix requires Linux to run, so it's not like technically uh, reproducible on every system, because
Right.
on Windows it uses WSL, which is Linux, and on Mac OS it works because Mac OS is Unix based, and Linux is also Unix based. So that's why I think it works. That's the whole thing with Nix. It's not like actually completely uh, reproducible on all systems. It is dependent on Linux.
Adarsh, Dominic said that there's a thing called garmix.com. It's in the chat.
Yeah, so Garnix is kind of like it's not necessarily an alternative, but it can be an alternative to GitHub Actions and configuration stuff. So it's cool because you just need a flake.nix, and you can do a lot of very interesting things like integration tests, smoke tests, and things like that, as well as just having everything set up on XOS server just using that flake. Actually, I was just reading yesterday. There's a book that it's written by this guy who works at Mercury, which is a credit card company. So he's actually writing a book called NixOS in Production, which you can download for free from LeanPub. I'll post the link in the chat. But the reason I bring it up is that he produces like incremental chapters every now and then, and he just released one yesterday talking about interfacing with Docker and some of the things that you're talking about right now, actually, in terms of configuration. So you can just read the last two chapters that he had and see if that helps. I don't really have the bandwidth right now, to be honest, to kind of really dive deep into this.
Yeah, so I advocated for dev container because we are already using Docker for everything, right? So if we bring Nix into it, we have two things to manage now. With dev container, we just have to use Docker containers, and everything is
No, but
configured in
I'm saying
Docker
that you can just use everything that you have now and just have
Yeah,
a Nix overlay in it, and it would actually
I
have
know.
less overhead because it
I
wouldn't
ha-
be caching the layers
I
individually.
have tried learning Nix, but it's like too hard for me.
Yeah, it is. It is very difficult. Like it's not. It's not.
There's no proper documentation for it.
Yeah, that's true.
Uh, I'll see what I can do. I don't know.
I mean,
If this doesn't,
the truth is that the most practical solution is to do what you're doing now. But if as the project grows, we kind of need to maintain some kind of sanity. Like we need to ensure that if one thing changes, everything doesn't break. And ideally, we should have something that when one person using it, like being able to just use a single command should, build the app and run it and perform integration tests depending on what folder a file is in. Like the setup shouldn't be too onerous and cumbersome.
yeah, I think all that will be covered by Docker. The only thing that's remaining is the
I can't hear you.
Adarsh, there's no audio.